Hey guys, today we are going to do the other part of 4-7 scientific notation. Now we're pretty good at interchanging standard form and scientific notation form. So today we're going to look at how we compare numbers, how we could order them, and then how we multiply scientific notations. Okay. So first thing we're talking about is comparing our numbers. So it's going to ask us to compare numbers using less than, greater than, or equal to. So what we're going to do for this is I'm going to put these numbers into standard form, and then I can compare them and see how they are similar or how they're different. Okay. So I'm going to start with this one. 403.6 times 10 to the negative 9. Remember, when you have a negative exponent, you are going left. And if you have a positive, your decimal place is moving right. Okay, so negatives. It would make sense because left is our smaller numbers. Negative exponents mean small numbers. And positive exponents are big numbers. Okay, so 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my new decimal. And I gotta fill in all of these spots. Okay, let's try our other one. 4.306 to the negative 8. Whoops, I might not have left myself enough space. 1, 2, 3, 4, 5, 6, 7, 8. Fill in all your zeros. Sweet. Okay, so I got these two numbers and I got to compare them. They look like they're a lot alike, but let's look at the zeros in front of them to see if they are the same or not. So I have on this one 1, 2, 3, 4, 5, 6 zeros. On this one I have, I've got 6 of them. Here I have 1, 2, 3, 4, 5, 6, 7 zeros. Okay. So which one is going to be bigger? One with 6 zeros or one with 7 zeros? The 6 zeros will be because there's less of them. So our symbol right here would say that this number is greater than this number. Okay? So that's one way you can do it. Put it into standard form. Take a look at your numbers. Okay, here's another example for you. Try and leave my note up there for you. There we go. All right, so on this one, we have two different numbers. One's in scientific notation, one does not. So let's put them both into scientific notation. Why not? Okay, so I'm going to take my decimal and I'm going to move it 1, 2, 3, 4, 5 to the spot. So I will have 5.05. Okay, that 0, when it's between numbers, it matters. When it's not, it doesn't matter. I didn't say that in the video before, but you got to keep those zeros between numbers. Okay, times 10, and let's see how many times do we move it. 1, 2, 3, 4, 5. So 5.05 times 10 to the 5th, 5.05 times 10 to the 6th. Which one do you think is bigger? Well, this one right here, 10 to the 6th, that one has more zeros on it. So I think that one's going to be bigger. Okay, you could also, if it makes more sense for you to be in number form, let's move this one to number form. 6 zeros. 2, I got to make that a bigger number. 3, 4, 5, 6. Going to the right. Filling in my zeros, so I have 5, 0, 5, 0, 0, 0, 0. And I'm going to add my commas. And on this one I have 505,000, and on here I have 5 million. We know that 5 million is more. So the more exponents on this big number means a bigger number. Okay, so on this one, we could make a note that says bigger exponent equals bigger number. So right here, we knew our exponent was bigger. We have a bigger number. Okay, I'm going to go back up here and see if I can figure that, that note out, the bigger exponent, bigger number. See how that works with our decimals, okay? So on this one, I'm going to put these, this is in proper scientific notation because there's only one number in front of my decimal. And I need to move this one in proper scientific notation. So I'm going to do it from here. I'm going to go 1, 2, 3, 4, 5, 6, 7. So I'm going to have 4.036 times 10, and I went 7 to the negative 7. Which number over here was bigger? It looks like the one on the left. The one on the left. Okay. So right here, what happens? It looks like bigger exponent is a bigger number because this negative 7 is technically bigger than negative 8. So this worked up here with the decimals. It worked down here with whole numbers. Okay, so bigger exponent is going to be a bigger number. So let's take a look on what if we do that same thing with ordering our numbers from least to greatest. These two are already in scientific notation, so I'm going to take this one and put it in scientific notation as well. Okay, 3,800,000. So decimals at the end, and I'm going to move it over 1, 2, 3, 4, 5, 6. So that one will be 3.8 times 10. And I moved it 1, 2, 3, 4, 5, 6. 10 to the 6. Okay, so let's look at our rule from before. It said bigger exponent means we have a bigger number. So these two have a bigger exponent. So let's start with them because this one's only a 5. Okay, which number, 3.9 or 3.8, which one's bigger? 3.9 is a little bigger. So 3.9 times 10 to the 6th, that's the biggest number. Whoops, this says from least to greatest. I gotta read the directions, huh? Okay, so biggest exponent means bigger number. These have the biggest exponent. So this is going to be our least because Mrs. Astaire doesn't know how to read directions. Okay, here we go. So we did that one. Okay, now we got to look at these two. They have the same exponent, so let's look at the numbers. This one is a smaller number, so that one goes next. Usually they want you to write it in the form it gave you from above. Okay, makes it more confusing, I know. And then this was our last number left. So here it is ordered from least to greatest. Smaller exponent is a smaller number. A bigger exponent is a bigger number. Okay, last one. Find the product. Write your answer in scientific notation. So we're going to use a property from a long time ago that you guys maybe liked called the commutative property. Okay. We're going to add into that our knowledge of exponents. So commutative property in multiplication says if we are multiplying everything, we can move them around in any order we want. So on here, we are going to multiply numbers, okay, times our exponent numbers. Okay. All right, so when we multiply numbers, we can either multiply them in our head, we can multiply them on a calculator. So I'm going to do it on my calculator, which turned off. 1.5 times 5, okay? So that is 7.5. I know my answer is going to be in scientific notation, so I'm going to put an X. And what happens when we multiply numbers with the same base? What do we do with the exponents? Okay, we add those exponents. So -4 plus 3. So what is -4 plus 3? -1. So our answer will be 7.5 times 10 to the -1. What happens if you multiply your two numbers? Let me see if I can think of an example. Okay, so what if I have this one? Okay, my exponents don't matter as much there. Okay, I have these two. I just made up a problem. All right. Hey, I'm going to multiply my numbers. 5 times 9.8. And then 10 to the 4th times 10 to the 6th. All right, so 5 times 9.8 is 49. Throw it on a calculator. We know it's going to be a scientific notation. We're going to add our exponents, 4 plus 6. Okay. Is this number in scientific notation form? It has one number in front of the decimal. The answer is no. So we have to change it. Okay. We're going to put our decimal in the end. We're going to move it over one space to make it 4.9. We took our bigger number and moved that decimal over one space. So that means we need to add one space to that exponent. We made this smaller, so we needed to make this bigger. Right? So if there's not one number in front of the decimal, you will need to adjust it so there is. All right. Have fun working through your IXL assignment. If you need to watch this again, that wouldn't be a bad idea. You can also watch the one from last class as well if you need a refresher on how scientific notation works. Have fun.